Now, hi, I'm Pranavi. I work as an observability engineer at Canva. I'm a new starter at Canva. It's been, I think, around 9 weeks now. So learning a lot, and it's been pretty awesome so far. Just before I joined Canva, I worked as the lead SRE engineer at Campaign Monitor. So for those who don't know about Campaign Monitor, they're a really cool email marketing company. So a lot of big companies like Rip Curl, Australia Red Cross, they all use Campaign Monitor to engage with their customers via emails. Like they send millions of emails every day. So what I'm going to talk about today is our journey to building observable systems at Campaign Monitor. So how did this journey begin? It was one fine day in December 2018. I got rudely awakened by a pager call at 2 a.m. 2 a.m. is always a perfect time for pager to blaring. So I had recently joined the SRE team, and I was just, getting into the on-call experience and stuff. So I got paged. I woke up, and it was about a monitor. So it was about a monitor saying that RabbitMQ has too many messages. So yeah, I was like, cool, RabbitMQ has too many messages. I know what the problem is, but that was about it. I didn't know why. I didn't know which service was consuming it. I didn't know whether there was a problem with any downstream or too much load, like no idea. Because it was my first time, I had the team lead to shadow me. So we both were working out the problem together. So at that point, I was trying to see, I couldn't figure it out straight away. So I was trying to see how was the other person troubleshooting the problem. And a few things stood out. For example, the team lead kind of knew straight away which service was consuming from the RabbitMQ, and also knew what the dependent services were. And we were able to figure out that downstream there was a SQL issue, and hence all this problem happened. So there was a lot of assumed knowledge in there. So the issue got resolved. We did like an incident response and stuff. And this gave me an opportunity to kind of reflect on what actually happened that day. There are few problems that I uncovered. The first thing is the tribal knowledge. There's so much information that the team lead knew that I did not. And Campaign Monitor had really strong engineers who've been there for several years, like for example, 6 to 7 years. So they've built so much knowledge over time that it's really hard for them to see what's missing. And there was another problem because the team lead was going to leave in a few months. So I was like, this, how am I going to ever get so much knowledge transition? It's not possible. And Campaign Monitor is also growing, and it's a polyglot environment. So it started as a C# stack, and then they moved on to Go and Java. Forget a person, even for a team, like the SRE team, to have knowledge of what's being built, what's going out, it's really, really difficult. So the one main problem we had to solve is not rely on the tribal knowledge or engineers to kind of fix the problems, but to have observable systems. So what do I mean by an observable system is, for me, if I can understand the inner workings of a system, not because I wrote it, not because I know I made a code change, so I know how it works. None of that. If I understand the workings of a system from the external information that the system emits, then I would consider the system to be quite observable. For example, say when I woke up at 2 a.m. and I knew what the problem was, but if I was also able to identify why with the information from the system, then that would be a pretty good observable system. So how do you build this kind of system, right? You just can't hope to have an observable system. You really have to build it. So it's a very conscious decision when you build a system that you have to emit the right events. So we can have some other system to aggregate the data and to make sense of it. So with regarding to events, I've kind of categorized them into logs, metrics, and traces. I'm pretty sure everyone's familiar with logs and metrics. Traces, a lot of companies are getting into them at the moment, but they're like super useful. So when we first began this journey of let's improve the observability at Campaign Monitor, the first thing that we did was to look at logs, find out what were the gaps there, improve them. Then we moved on to metrics. And at that point, we didn't have traces. So we found the gap and then we had to introduce tracing. So let me just go through each phase one by one. The first thing, like I mentioned, the logs. There were plenty of logs, like no issues with that at all. Like everybody loved logging stuff. Our system was always flooded with logs. But and then we had a really nice centralized logging system. So we used AWS Elasticsearch for all the logs, and we used Graylog to access it. The problem was searching for the logs. The problem was finding the right logs. So the first thing we wanted to solve is to have a really good structured logging system. So there are a few examples here, completely random examples. But as you can see, as a human, I can understand, I can read the log message, right? It says it's a timestamp, it's like a user ID or some form of an ID, and it gives me like a method name, etc. But as a machine, it doesn't really understand this line of log. It can't automatically parse. It can't automatically strip them out as fields. Especially with using a really powerful system like Elasticsearch, which can do amazing aggregations and everything, it'll make more sense if the log message is structured in a format like that, where we give specific fields and specific values, so we can actually search by a field. We can aggregate by the result. So it was really crucial to have structured logs throughout the system. So there were some systems that had it, that some systems didn't, but there was no consistency. So we went about having like a more consistent way, which kind of meant picking a library, for example, Serilog for C#, and rolling it out across microservices, across monolith, across all the services, and enable the developers to actually use this. And then, when you look at the log message, it's so much more useful. And especially when you are dealing with an unknown system, having all these fields show up in the searching system kind of tells you, oh, okay, this log message has a resource, so maybe I can search by it. But if it was just a plain string, you had no idea, what string you can search for in the logs and things like that. So the first thing that we improved was to have a really good structured logging across the system. And the next thing moving on was correlatable logs. Forget microservices, right? Even within a single service, a request travels through multiple classes and they all have their own log messages. Especially if it's like a multi-threaded system, it's really hard to kind of see the journey that one request has throughout your system. So it's really important to add a context to every single log message. So you could go to a naive approach where you can pass this context through every single function, but that's not optimal. You can't do that. So what you could do is a lot of the libraries support adding context to like something like, say, a thread context or MDC utils in case of Java. So when you add this context, say a request ID or a client ID, it is carried throughout the processing of the request, which means and every single log message will look for this contact information and will automatically add it to the logs. So this really helped us because we have a lot of batch processing happening and a lot of multi-threading happening, and it previously everyone relied on kind of using timestamps and stuff, but very soon once we had correlatable logs, it made a world of a difference to kind of go through one batch of messages and see what happened end to end. So with structured logging and enabling correlatable logs, there was a significant improvement with respect to the searchability of the logs. So once we knew kind of what to search for, it was so much easier to get the information. And in order to have some consistency, like I mentioned, because we had a polyglot environment, it was kind of important to pick the libraries and kind of stick to them. So for C#, Serilog was really, really good. And for Go, zero log, and for Java, it was SL4J with logs-logback encoders. We kind of had this consistency across the microservices and our monolith, so it kind of significantly improved searching logs. So once we were satisfied with our logs, so we moved on to metrics. So metrics are, again, events which are aggregatable. They're amazing to kind of give you a really good bird's eye view of the system. You can create dashboards with metrics. You can create alerts. There are great service level indicators. And we used Datadog for all our metrics. Like Datadog collected all our metrics, and we were able to create monitors and alerts, sending them to PagerDuty. All of our engineers really used metrics quite well, and it was used extensively. What was missing was, again, key metrics. So we couldn't identify, or not all the services had all the key metrics. Say, for example, every single service has inputs and outputs. For example, it could be reading from an SQS message, writing to a SQL server. So for each of this input and output, it's really crucial to have these key metrics, which are traffic, what is the load, latency, how long is it taking to process the request, what are the total number of errors, and if it's another service that you're reading from, what is the saturation of resources on that specific service. Having these key metrics for every input and output would really help to kind of narrow down where the problem is. Because if this is not consistent, like say if some inputs have these key metrics and some outputs don't, it's really hard to diagnose in a microservice kind of an environment where the problem is. Is it the input, or is it the output, or is it the service itself? Like there's so many questions that's very hard to be answered if we didn't have all these key metrics. So it was really important to kind of ensure that if you had an input and an output, to have all these key metrics configured. And another important thing was every service kind of had this way of naming their metrics. They had the service name in the beginning, followed by the metric name, which was HTTP requests total. This worked as long as just the team needed to look at the metrics. But imagine as an SRE team, when we had to look at the metrics across the board, we wouldn't know that we had to look for payment service or auth service and things like that. So what would be really ideal is to have a standard metric name, which is HTTP request or total, and then tag them by the service. So we can have even one dashboard that covers the HTTP request across all the services. So this was also quite an important change to give the SRE team a much, much better visibility of what's happening across the board. So we were at a good stage, right? We kind of improved the logs a bit. We kind of improved the metrics a bit. So we were like, yeah, I think we are in a good spot now. But still, there was a gap. There was a gap in observability. So with respect to logs, like I mentioned, you always need to know what log message to look for. So again, this was another interesting incident. So I got paged, again, middle of the night. So I knew it was there was a service. It was struggling to keep up with the load from a Couchbase server or something. So I knew I had to scale it up. I scaled it up, resolve the issue for the night, but I didn't know why. So next day morning, I go to the team and then I ask them, why was this extra load? So what was actually happening? The team immediately looked at the logs and said, oh, it was because there was a key sync or something happening. I was like, how? I was looking at the logs for a couple of hours last night, but I couldn't find it. It's because the team knew exactly what log message to look for. They looked for a message called key synced. I wouldn't know what log message to look for. And that's when it was really, really evident that unless you knew what to look for, logs weren't super helpful. And logs are great for forensics, right? Like what I did, I solved the issue. The next day, the team was able to look at the logs and find out what the problem was. So it's a great forensic measure, but it doesn't give you a live picture of what's happening with your systems. So that's how much logs could cut for you. And then even with metrics, right? Like it would give you that bird's eye view. It will give you a holistic understanding, how healthy your systems are. All that's great, but it doesn't give you the depth that you need. Like cardinality comes with a huge price tag. For anyone who's used Datadog, you would know that anytime you add extra custom metrics, you are charged quite heavily. So we had to really restrict what tags that we had to add on all our metrics. So with logs and metrics, we kind of knew that this is how far we could go. There was something missing beyond this. And like I mentioned, with logs and metrics, we got to a good state where if we knew that there was a problem with this service, we could try to find out, is it this service's fault, or no, let's try this service, or this service looks healthy, okay, let's try the downstream. Some teams had good dashboards, so you could kind of see the inputs and the outputs, and for those that didn't, you kind of had to have some knowledge. You needed to know what the upstream and the downstream was to kind of find the issue. So that's when we introduced distributed tracing to Campaign Monitor. So we kind of, how it started was we came across this blog from Datadog about their new APM feature. So we thought, let's do this. Let's just enable, because we already had Datadog agents in all our instances. So we thought, let's just enable APM. Let's just install their default library, Datadog library. It came with some basic instrumentation for HTTP requests and SQL. So we thought, let's just do that and see what it looks like, because we want to know if it's worth the investment. Just with that, basic level of HTTP requests being traced and SQL being traced, we got an enormous amount of insight into what a system was actually doing. So the best way for me to kind of explain the benefit is I thought I'll steal some pictures of Datadog's blogs. So basically, again, traces are also events, and say span and trace, they're all events. And span kind of represents like a single unit of work. And one span relates to another, it can have a parent-child relationship. So you can kind of see the flow of a request, like which request called into another request, it called into another service. So you will be able to add all of this metadata into a span. And trace is like gives you end-to-end look into a request. It's also a span which doesn't have like a pattern, because it's like the root span, like it's like the topmost span. And you can actually see the picture here. It kind of gives you like what happened when we got like a GET request on the user's API. So basically, it kind of made a call to Redis, it made a call to SQL Server, but in between, it also had some errors here. And you can also have the services. So previously, it was really so many incidents, right? We kind of figured out by using traces. Things like we would see 3,000 SQL Server calls here, even though they would take only a millisecond. So you couldn't really spot it in a metric or something because it was super fast. And we were like, why is this making 3,000 calls? And we would figure out that there was a for loop and there was a SQL Server within the for loop, a SQL Server call, and hence it was bashing the SQL Server. Because we had massive ones, it didn't really cause a problem. But there's so much insight that we wouldn't have known, previously, was all transparent once we introduced tracing. So once we were really happy with the results, we went ahead and heavily invested in tracing. So with tracing, right, like I mentioned, you can also have, if there is an issue with the span, and if you had instrumented to kind of add this exception on the span, you would just be able to click the span and see what the exception was. You wouldn't have to go search for it in Graylog. Like it was a pattern and it was right there. And the next thing is all these key metrics that I was talking about comes by default. Again, because span is just an event, Datadog will aggregate it for you. And for every service, it will give you what was the total requests, what's the latency, the total number of errors, and total time spent per service. That was really important. So you can see as a service, am I spending maximum time on Redis, or am I spending a lot of time on SQL? So you can actually get this per service breakdown all just by having spans and traces. So once we have this, we were even able to remove a whole bunch of duplicate metrics because we already had total requests and errors and latencies. So we can then focus on more important or more relevant metrics per service. So once we added service, you can also get a span summary. So you would know even to the detail of which SQL query was the one that took the most amount of time, and how many of these SQL queries that we actually executed. So you can have all this information by instrumenting your application to have spans and traces. And another really cool feature was obviously you have to have a service map. So it's like really nice way to see what the requests were, what the services were, and it was really nice way to kind of see another really nice bird's eye picture of what was happening. And I actually kind of sound like I'm an ambassador for Datadog. Full disclosure, I'm not working for Datadog. Datadog is not paying me to do this. But Datadog's APM feature kind of helped campaign monitors significantly with this whole observability journey. There are so many APM products out there, but this kind of fit our gap, and it really helped us with our journey. So all this kind of information that I gave you about how awesome tracing is, it's not possible without instrumentation. It needs heavy instrumentation. So once we were kind of happy with the base level information, and then we decided to go to every single service of ours and add these spans and traces. I just have this really small snippet of code, what it means to add a span. Is, say, for example, if sort orders is a function that I want to track, so I would just literally create like a span around it. So this is a C# code. Using is like once this function is over, it would automatically close the span. So these are the tiny spans that you see. So say this whole parent-child relationship that I was talking to you about. So you can have a parent span, and then you can have like multiple child spans. So basically, the sort order span that you see here will kind of consist of all these other child spans going forward, and it'll give you a really nice flame graph that I showed you before. So these, again, CM being a polyglot environment, there were quite a few services. We used Kafka, SQL, Redis, Couchbase, gRPC, SQS, RabbitMQ, all of these awesome services. So it was really important that we, even across all the languages, so it was really important to kind of have a very similar, and a consistent structure for tracing across all these services. And when, for example, for SQS, if I wanted to make sure that the producer and the consumer of an SQS message were being able to link in a trace, so I would have to pass the trace ID and the span ID in the SQS metadata, and then the consumer will consume it and use that trace ID and span ID as the parent. This goes for any of the things like RabbitMQ or gRPC. So we kind of had to come up with ways of how we are going to carry forward, this trace context across distributed services. It was a couple of months of work, but it was totally worth it. Like at the end of it, some of our architectures, for example, it would use a Go service and a Java service and a C# service with, in between a couple of Kafka topics and stuff. So to be able to see end to end a service like that was pretty amazing, and it wasn't possible. And the amazing fact is, if someone introduced another service, I didn't have to know about it. Like if I looked at the trace, I would be able to see all the services that were involved in solving or giving a solution for that specific request. So it was like a significant game changer, having to see everything end to end. So we at this point, right, we kind of had best practices for a lot of things. We had best practices for logs, we had metrics, and we had tracing and everything. But just one team couldn't do everything end to end. So we really needed the developers to kind of help us with this journey as well. So one of the most important things to do was a production readiness documentation. And the reason for this is, for example, when you have a service and when you want the SRE team to take over the production on call for this service, we needed the teams to fill this documentation, and it had all the checkpoints. Do you have structured logging? So does your service use correlations? Do you have the right key metrics? Are you using the right libraries with tracing in them? So this was really like one thing that tied up the entire the entire journey, because at this point we were quite confident with all the improvements and we wanted every team to follow it, and we also wanted a checkpoint to make sure that every service kind of had it. So finally, with this kind of rolling out, so every team was able to see what was missing in their service and kind of add more metrics or tweak their logging and things like that. So this kind of sealed the deal for the entire journey. Personally, I'm always really interested in the cost, because some of the most sophisticated distributed tracing libraries are very, very expensive. So we kind of had to always keep cost in mind. And whenever anyone talks to me about their observability system, I always ask them, "Oh, how much does it cost?" Because it was really, really interesting to see how much people are willing to spend on the observability platforms. For Campaign Monitor, we spent around $160,000 USD on Datadog for metrics and traces. And for our log pipeline, we used Graylog and Elasticsearch. So that was around 54,000 USD. So it was pretty good. And we also we had to justify, like, do you think we're getting the benefit by spending so much? But I can definitely say that at the end of this, the on-call experience was just so much better. So waking up at 2 a.m. was not that scary anymore, because you didn't have to also go hunt down why, because the why was always obvious. You just had to go now and fix the issue. So the overall journey, which took a couple of months, really paid off. And that's pretty much what I had to talk about observability and the journey. So thank you. It's so hard, the remote.
One second. Pranavi, thank you very, very much for your presentation. It was fantastic. And now we are preparing for our panel, so don't go anywhere. Just give us a little bit of time to set up the video from everyone properly, and we should be ready to go. So just 1 second. Let me. Pranavi asked me to just give her 1 second for a plug. Let me switch the screen. You have voice?
Oh, okay, awesome. There was one thing. So even though I spoke about Campaign Monitor a lot, it's an awesome company, but now I work with Canva, which is amazing as well. And then we are hiring. So if anyone's keen to work for Canva, please do apply. Be awesome to work with some cool engineers. Thank you.
All right. So I'll let our panel speakers set up, and in the meantime, we will dissolve for a very short break. Like, give us like 3 minutes or so.